Chapter 4, Unit 2. We're going to talk about standard deviation in this chapter. This is the most commonly used and most important measure of variability. The standard deviation measures the distance each score is from the mean, it squares each of those distances, and then it adds them up. A deviation score is just a distance from the mean. So for example, to find the deviation, you would just take a score x and subtract the mean. And you might see the mean as mu if you're talking about a population, or as m if you're talking about a sample. So either way is correct. So let's look at some examples of just finding a deviation. So let's say you have a distribution of scores with a mean of 50, and you have a score of 53. Well, to find the deviation, you just say x minus the mean, which is 53 minus 50, so the deviation score is 3. That means you are deviated 3 points away from the mean. Okay, let's try it again. Say you have a distribution of scores that has a mean of 50, but this time your score is 45. Well, your deviation score, which means how far away are you from the mean, is x minus the mean, which is 45 minus 50, and this time you have a deviation score of -5. So each deviation has two parts. You have the sign, which is positive or negative, and then you have the number. So positive indicates the score is above the mean, and that's like the example that we did at the first. 53 minus 50, we ended up with a positive 3. So your score of 53 was above the mean. Now if you end up with a negative score, this indicates the score is below the mean. For example, example 2, where we ended up with a -5. Because our score of 45 was below the mean of 50. So the number actually just tells you how far away the score is from the mean. So let's look at an example. So here's some scores, 8, 1, 3, and 0. I want you to calculate the deviation scores. The way we do this is we use a table. We list all the scores in the table. So we would list 8, 1, 3, and 0. The second step we would do is we would sum up the scores, and if I did a summation of x here, I would equal 12. The next step we do is find the mean. So summation of x is 12, n is 4, there are 4 scores here, 12 divided by 4 is 3, so I have the mean. The next step is I'm going to make a deviation scores column. Since I know the mean is 3, I have to do x minus the mean. So my column is going to be called x minus 3, since 3 is the mean. And then I take each number from the first column and subtract 3 to get my new column. Notice that if I add up these deviation scores, the sum is always going to be 0, because you're going to have equal number of points less than the mean and equal number of points greater than the mean. Okay? So, and these values in this second column are called deviation scores. So the deviation scores for this example are 5, -2, 0, and -3. Okay? And again, if you sum them, it's always 0. If you actually take a third column and you square those deviation scores, so you would square 5 and get 25, you would square -4 and get positive -2 and get positive 4, you would square 0 and get 0, you would square -3 and get 9. So if you square those deviation scores, that's called sum of, and then sum them up, you would have sum of squares, which we abbreviate as SS. Okay, and we use SS in order to find variance, which is then used in order to find standard deviation. So first thing you do is make the second column with x minus the mean and find deviation scores. The third thing you do is you square every score and add that up to find a sum of the squared deviation scores, or SS for short. Okay. So in order to find variance, the equation for finding variance is you just take the sum of scores you found, 38, and you would divide. You would divide by n if you have a population, and if you would have a sample, you would divide by n minus 1. And we'll go into the reason for this a little bit later. Just know that there's a difference. So in this problem, we're going to say 34 38 divided by, parentheses, 4 minus 1, since we're talking about a sample here, which is 38 divided by 3, which gives you a variance of 12.67. The last step is you have to know that squared distance scores are not always the most useful. So what we need to do is find one score that would be useful that wouldn't be squared. So we just take the square root of that variance. And what we're looking for is called the standard deviation. So in this example, we found a variance of 12.67. Well, the standard deviation is just the square root of that, or 3.56. So let's look at another variance and standard deviation example. Step 1, list the scores in the table. Step 2, sum them up. In this case, you would get summation of x equal to 30. Step 3, find the mean. Again, it's just summation of x over capital N. We're going to assume that this is a population. So 30 divided by 5, which is equal to 6. The next step, we're going to create another column for x minus the mean. In this case, we found a mean of 6. So our column is titled x minus 6. And then we subtract 6 from every single score, every single original x. And if you want to make sure you did it right, you could add them all up and you would always get 0 there. These are the deviation scores. Okay, the next column you need to create is the deviation scores but squared. So you're going to square each of the deviation scores to get a new column. Then you're going to add them up. And this is the sum of squares, or the sum of the squared deviation scores, if you want the full name. Okay, and we need this SS, this sum of squares, in order to find the variance and standard deviation. So calculate the variance. You just take the sum of scores, divide by n, how many you have. So you're finding the average. So 40 divided by 5, it gives you 8. So 8 is your variance. And then if you wanted to find the standard deviation, you would just take the square root of 8, which gives you 2.83. All right, sometimes we just want to estimate standard deviation. I want you to look at this normal curve. You will notice that there's a mean symbol in the middle, mu, and if you go out one standard deviation, and the standard deviation is a Greek symbol, looks like a row, looks like a little circle with a line coming off to the right. Okay, that's mean plus 1 standard deviation, and then you see to the right of that mean plus 2 standard deviations, and then to the right mean plus 3 standard deviations. And if you go back to the middle and go to the left, you'll see mean minus 1 standard deviation, and then mean minus 2 standard deviations, and then mean minus 3 standard deviations. So what we know is between mean minus 2 standard deviations on the left and mean plus 2 standard deviations on the right, that is 4 standard deviations. And that's about 95.4% of all scores are within 2 standard deviations. So we use this in our estimating. Okay? So if we know the mean in the middle, and we know the number that's furthest away from the mean, we can estimate that that's about 2 standard deviations from the mean. So in order to solve these problems for estimating, you first find the mean, then you find the range between the mean and the number that's farthest from the mean, whether it's on the left or the right, it doesn't matter. And then that number, whatever that range is, you just divide it in half, because that number is most likely about 2 standard deviations from the mean, and we want to know what 1 standard deviation is. So we're going to divide that range by 2. So here's another example. Estimate the standard deviation for these scores. The mean is summation of x over n, which is 30 divided by 5, which gives us 6. We find the range of score that's the furthest from 6. Well, let's look at the smallest score in the set of data. It's a 1. So the mean is 6. So the range would be 6 minus 1, or 5. Well, let's look at the largest score in that data set. Well, it's a 9. Well, 9 minus the mean, 9 minus 6 is 3, 3 points away. So which range is the biggest? Well, the 5 points away is, right? So we use that range of 5 points because it's the largest range. And then we estimate the standard deviation by dividing that range by 2. So we say standard deviation is equal to 5 divided by 2, which is 2.5. I also want you to just look at this graph here. So if we take these points and we make a histogram for these 5 scores, We can label the mean. We found the mean of 6, so we can label it with a line, and at the top right, mean equals 6. Okay. You can find the smallest distance from the mean, which is 1 point, and you can find the largest distance from the mean. Again, we said the largest distance away from the mean was at a score of 1. It's 5 points away. Okay. So if you do that, you also kind of know that the standard distance or the standard deviation should be somewhere between 1 point and 5 points, because the smallest distance away from the mean and the largest distance away from the mean. So that's another way to look at it. So let's do the learning check. Which of the following scores has the largest variance? Okay, stop the video, see if you can do it. All right, so when we talk about variance, we really just means which scores are the most spread out. So you don't have to solve for variance. You can just say which scores have the greatest range because they'll have the greatest variance. They're more spread out. So in the first case, I said the largest score minus the smallest score, 12 minus 1, has a range of 11 points. For B, 15 minus 12, largest minus smallest, has a range of 3 points. For C, there's a range of 0 points. All those scores are exactly the same. None of them are spread out at all. And for D, 27 minus 22 has a range of 5 points. So which one would have the largest variance? Well, the one that's the most spread out. That would be A. That would be your answer. All right, learning check problem 2. What's the variance for the following scores 4, 1, 7? Stop the video, see if you can solve it. First off, assume that this is a population. So in order to solve for the variance, you would first make your X column with your scores 4, 1, and 7. You would find the summation of X, which would give you 12. You would find a mean, which would give you 4. Because 12 divided by an n of 3 is equal to 4. So once you have a mean, then you can make the next column, which is X minus the mean, or X minus 4. You subtract 4 points from every score. And again, if you want to check yourself, you can add them up and make sure it adds to 0. Finally, you do your third column. You take those deviation scores and you square them all. And you get a total of 18, which is your sum of squares. So that's your sum of square deviations. Now you can do a calculation to find variance. Well, variance is just sum of squares divided by n, which is 18 divided by 3, and you get 6 for your variance. And if I had asked for the standard deviation, you would simply take the square root of 6 to find a standard deviation. Learning check problem 3. Pause the video, see if you can solve the problem. All right, step 1, you always find the mean. In this case, it's 18. Step 2, find the range of the score that's furthest from the mean. Well, in this case, the smallest score is 12. So how far is it from the mean? Well, let's just subtract and find out. 18 minus 12 gives us 6 points away from the mean. The largest score is 24. So subtract the mean from that and get 6. And in this case, I don't care which number you put first, the score or the mean. I just want to know which one's further away. Both scores are furthest away. They both have a range of 6. So you estimate the standard deviation by dividing that range by 2. So standard deviation is simply 6 divided by 2, which equals 3. So 3 is our estimated standard deviation.